Today we are going to be looking at section 5.5, which is on applying the remainder and the factor theorems. Our goal is to use these theorems to factor polynomials. So far we've continued to look at how to factor polynomials, whether they were trinomials. A couple days ago we looked at factoring polynomials with 4 terms. Now we're going to be able to factor polynomials with any number of terms. So that's what the remainder and the factor theorems are going to help us do. The first thing we're going to talk about is something that you all enjoyed thoroughly, and that is long division. Remember back in the days, this is probably a long time ago that we looked at how to do long division, and polynomial long division is almost identical to that. So polynomial long division is a method used to divide polynomials similar to the way you divide numbers. So what we're going to do first is we're going to look at an example, and we're just going to make a number up here. We'll say 57,621 divided by 7. So remember, when we did long division, we had to figure out how many times does 7 go into 57. All right, well, 7 goes into 57 8 times. And then 8 times 7 was 56. So you subtract those. And then that is 1. And we brought down the 6. How many times does 7 go into 16? Well, 7 goes into 16 twice. 7 times 2 is 14. And then we subtract those two. 16 minus 14 is 2. And we bring down the 2. So now how many times does 7 go into 22? And that is 3 times. 3 times 7 is 21. And 22 minus 21 is 1. We bring down the 1. How many times does 7 go into 11? And that is 1 time. So that 7 times 1 is 7. We subtract those two. And 4 is our remainder. So we're going to say plus 4 11ths. And that is how we did the long division. Well, the polynomial long division is going to be exactly the same type of problem. And hopefully we have enough room here to get this in, but we're going to do the same thing. We're going to say we have x cubed plus 3x squared minus 7. I'm going to need a little bit more space than that. X cubed plus 3x squared minus, we're going to have 0x minus 7. Remember, just like we did the other day, you have to have every column represented. X cubed, x squared, x. I don't have one here, so I have to put a minus 0x, minus 7. And then I'm going to have, whoops, well, I'm going to write it this way. X squared minus x minus 2. That's the number that goes on my left side. So, just like we did over here, how many times does 7 go into 57? We want to know how many times does x squared go into x cubed. So what times x squared is x cubed? So that is going to be x, because x squared times x gives me x cubed, which is what I want. So my answer is going to be x, and it has to go in my x column. So now I do the distributive property. X times x cubed, or x times x squared is x cubed. X times negative x is negative x squared, and x times negative 2 is negative 2x. And we subtract those. X cubed minus x cubed is 0. That first term should always be 0. If it's not, then you did something wrong. 3x squared minus negative x squared is 4x squared. 0x minus negative 2x is plus 2x. And then again, we bring down that negative 7. Well, now, how many times does x squared go into 4x squared? Well, what times x squared gives you 4x squared? And that's going to be 4. So 4 times x squared is 4x squared. 4 times negative x is negative 4x. 4 times negative 2 is negative 8. Again, we're just doing the distributive property here with those numbers. So now we subtract those two, and those are gone. We're going to get 6x plus 1. And so we're going to have plus 6x plus 1 over x squared minus x minus 2. And so here is our answer when we do the long division. Now, unfortunately, that is the only way to factor when we are looking at dividing by a trinomial. The next example, we're going to use polynomial long division with a binomial. We're going to be dividing by a binomial. And this is more like what most of the problems that we look at in this section is going to be like. So let's start with our problem. Again, we're going to have 3x cubed plus 17x squared plus 21x minus 11. Now, we're going to divide by x plus 3. So once again, we have to figure out what times x gives me x cubed. So if we're going to multiply, we want those to cancel out, so I need a 3x squared. So that's what's going to go in my x squared column. Notice in this problem above, all of these were x cubes, all of these were x squareds, all of these were x's, all of those were constants. Okay, so they have to be in that same column. So that's why our 3x squared goes here. So now we're going to do the distributive property. 3x squared times x is 3x cubed. 3x squared times 3 is 9x squared. Again, we subtract those. Gone. This is going to be 8x squared, and we bring down the 21x. So again, we have to figure out what times x gives me 8x squared. Well, that one's going to be 8x. So now, again, we do the distributive property. 8x times x is 8x squared plus 24x. Again, we subtract them. Gone. And we get negative 3x. Bring down the negative 11. Once again, what times x gives me negative 3x, and that's going to be negative 3. And again, we have to do the distributive property. So that's going to be negative 3x minus 9. Subtract those two. That's gone. We have negative 11 plus 9, which is negative 2. So this can be plus negative 2 over x plus 3. And there is our answer. 3x squared plus 8x minus 3 plus negative 2 over x plus 3. And in some books, and they might just write down remainder of negative 2. All right, so there is how to do long division. So what I would like you to do is do examples 1 and 2 using long division. First one, you're going to divide by a trinomial. Second one, you're going to divide by a binomial. So go ahead and pause the video until you are finished with those, and then you can hit play. And here are the answers to questions 1 and 2 in the guided practice. Again, we're using long division to, and we're going to use this to factor in the next few examples. But here's how you do long division using a trinomial and a binomial. Now the next thing we're going to talk about is something called synthetic division, which is almost identical to the synthetic substitution we used the other day. But synthetic division is a method used to divide a polynomial if the factor is in the form of x minus k. Now remember, this means that that factor must be a binomial. The only time you can use synthetic division is if this is a binomial. And once again, here is how that works. We're going to use synthetic division in example 3 to divide this polynomial, f of x equals 2x cubed plus 9x squared plus 14x plus 5 by x minus 3. So again, we're going to write our coefficients. And remember, again, we have to have every column represented. Now, if x minus 3 is a factor, that means x minus 3 is a factor, we want to know what is the 0. Well, it's 3, because if we'd solve it, we'd get x equals 3. So 3 is the number we're going to put in here. So this is going to be 2, 6, 15, 45, 59. 3 times 59 is going to give us 177. And then that's 182. So if we divide that, our polynomial function is going to be 2x squared plus 15x plus 59 plus 182 over x minus 3. So here is what we get when we factor this. Now notice, if we start with a factor of x cubed and we divide it by a factor of x, this will always be 1 less. So that's going to be an x squared. So if I started with an x to the 7th, this 2x squared would have been a 2x to the 6th. It's always going to be 1 degree less. And so this is the same way to do a problem as we would have using long division if that term is a binomial. Okay. So if this is a binomial, you may use synthetic division instead of a long division. If it is a trinomial, you don't have any choices. You must do long division. So then we're going to look at the factor theorem. And the factor theorem says a polynomial f of x has a factor of x minus x if and only if f of k equals 0, which is kind of what we talked about right up here. If x minus 3 is a factor, then I know that 3 is one of the zeros. All right, so here it says we can use the factor theorem to solve problems if, first, they give us one factor of the polynomial, then we'll be able to find the other factors. We can use the factor theorem if they give us a 0 to find the other zeros, and if they give us a solution, also to find the other solutions. All right, so if we look at example 4, they tell us that this x minus 3 is a factor. So I'm going to use synthetic division. It's a binomial. I'm not going to waste my time with long division. I'm going to go right to synthetic division. So we want to factor this completely. So we're going to have 2, negative 11, 3, and 36. Now, if they tell us that this is a factor, we automatically should know that we're going to get a remainder of 0. If we don't get a remainder of 0, we know that we did something wrong. So if x minus 3 is a factor, we know that 3 is one of the zeros. So that's what I'm going to put in here. So we're going to drop this down. So that's going to be 2, 6, negative 5, negative 15, negative 12, negative 36, and that is 0. Perfect. It came out. So it is a factor because there's a remainder of 0. Well, here's what this means. I know that x minus 3 was one of the factors. And now this tells me that 2x squared minus 5x minus 12 is also a factor. Because really what we did is divide this polynomial by this one, which means if I multiply those two together, that's going to be what I have. So we have to check, is this factored completely? So we have to look, can we factor 2x squared minus 5x minus 12? And the answer is yes. And once again, we need to remember how to factor. We have 2x and an x. Factors of 12 are either 1 and 12, 2 and 6, or 3 and 4. And we have to try to decide which one is going to get us to that negative 5 in the middle. So let's try 4 and 3. So that's going to give me 8, so that needs to be negative, and positive, so that's going to get me to my negative 5. And so here is my polynomial factored completely. F of x equals x minus 3 times 2x plus 3 times x minus 4. Now, if we multiplied all these again, we'd get back to our original equation. So what I would like you to do now is look at the guided practice questions number 3 and 4. Just use use synthetic division to divide those. So go ahead and hit pause and hit play when you are ready. And there's the answer that you get using long division when we have a binomial. Or sorry, using synthetic division when we have a binomial. Now, if you did it using long division, you would get the exact same answer. All right, so now that we're done with the guided practice questions 3 and 4, let's also look at questions 5 and 6. Now, this time they're telling you that x minus 4 is one of the factors, so we should get a remainder of 0. So they want us to factor these completely. All right, so go ahead and do questions 5 and 6. Pause the video and then hit play when you are ready. In using synthetic division, x minus 4 is the factor here. So that means 4 is the number that we are plugging in because that's one of the zeros. So if we factor completely, here's what we get for questions 5 and 6. Now the next thing that we're going to talk about in example 5 is we want to find the zeros. Well, if we look at the screen one in example 5, it says we want to find the zeros of that. Well, the zeros are where each of those factors would be equal to 0. So in example 5, 4 would be one of the zeros, 3 would be one of the zeros, and -1 would be one of the zeros. Again, we're just going to be using the zero product property like we talked about in chapter 4. In example 6, 4 would be one of the zeros again, so would -5 and +2. So using the zero product property, we're going to do the exact same thing in example 5. We want to find what the zeros are. So we're going to use synthetic division once again. And so here we're going to have 1, 1, -16, -16. We're going to put in 4. They tell us that 4 is one of the zeros, so we put it in there. And again, we should expect to get a remainder of 0 because if it is one of the zeros, we're going to get a remainder of 0. So this is 1, 4, 5, 20, 4, 16, and it is 0. Perfect. So if we would write this out, we know that f of x is going to equal x minus 4 using that as one of the zeros. And then we rewrite what we have, x squared plus 5x plus 4 from right down here. So if we would factor this completely, this is going to be x plus 4 and x plus 1. So now if I set this equal to 0, I know that either 0 equals x minus 4, 0 equals x plus 4, or 0 equals x plus 1. Well, in this case, x equals 4. What we already know. Here, x equals -4, and here, x equals -1. So -1 is the other one that's given there, but -4 would also be one of the zeros. So here we have 3 zeros, 4, -4, and -1. All of these numbers are solutions to that problem. All right, so if we jump down to example 6, now we're going to use a real-life situation. It says a company's profit C in thousands of dollars can be modeled by this equation. C equals -5x cubed plus 6x squared plus 15x, where x is the number of products in thousands. So the profit is $14,000 for producing 2,000 items. What other number of items could we produce the same amount? So we're going to put 14,000 in. However, you see here that it says it's in thousands of dollars. So instead of putting 14,000 in for C, we're going to put in 14. So it's going to say 14 equals -5x cubed plus 6x squared plus 15x. Well, we want to set it equal to 0. So it's going to be negative 5x cubed plus 6x squared plus 15x minus 14. So from here, we're going to use our synthetic division. Try to sneak it in right here. So we're going to say negative 5, 6, 15, negative 14. And they tell us that 2,000 items is one of the solutions. So that means I'm going to put a 2 over here. Because once again, we're in thousands of dollars. So 2,000 items, we have to divide by 1,000, we get 2. So we're going to go negative 5. That's negative 10, negative 4, negative 8, 7, 14, 0, and good. We just showed that 2,000 is, in fact, one of the solutions. So now we have negative 5x squared minus 4x plus 7 as our other factor. And this one is x minus 2. So we'd have to try to factor that. Now, in this case, it's not going to factor. So what are we going to do if we have a trinomial that doesn't factor and that it's a quadratic? We're going to have to use a quadratic formula. So we're going to say x equals negative b, which is 4, plus or minus. It's going to be b squared, so negative 4 squared minus 4 times a times c over 2 times a. This is going to be 4 plus or minus, and then we're going to have 16 plus 4 times 5 is 20. 20 times 7 is 140 over negative 10. So then x is going to equal 4 plus or minus square root of 156 over negative 10. And we're going to put our two numbers in. And this is well, let's do this. 4 plus or minus, I think square root of 156 is about 12.5. So I don't need that in there. So it's 12.5 over negative 10. So 4 plus 12.5 is 16.5. And 16.5 divided by negative 10 is negative 1.65. And then 4 minus 12.5 is negative 8.5 divided by negative 10 is negative, or is positive 0.85. Well, obviously, we cannot have a negative solution, so that's not it. So x must be equal to 8 or 0.85. However, once again, we need to remember that this is in thousands of dollars. So what would the other solution be? Well, we're going to need to multiply that by 1,000. So it's going to be about 850. So 850 would be another solution to this problem. So what I would like you to do right now is go ahead and do questions 7 and 8. They give us one of the zeros, and they say negative 2. So f of negative 2 equals 0 means that negative 2 is one of the zeros. So find all of the zeros. Now here it says find the other zeros, but I want you to find all of the zeros. That just means negative 2 is going to be one of those. All right, so go ahead and pause the video, and then you can hit play when you are ready to go. And here are the answers to the two guided practice questions, number 7 and 8. Notice using synthetic division, we plugged in negative 2. That's one of the zeros. We got a remainder of 0 on both of them. Then we factored these. We made sure to factor completely. Then we used the zero product property to find out what the zeros were. So again, section 5.5 is on applying the remainder and the factor theorems. We started out using long division, and you have to use long division if we're dividing by a polynomial that has more than 2 terms. Otherwise, if we're dividing by a binomial, we may use synthetic division, and we use synthetic division to factor down any type of polynomial so that we can find the zeros and the factors. So here is your homework assignments, page 366 for section 5.5.